So this is question 8. A ball is thrown vertically upward from the top of a building 80 feet tall with an initial velocity of 64 feet per second. The distance s in feet of the ball from the ground after t seconds is given by the equation s equals 80 plus 64t minus 16t squared. So it's interesting that quadratics actually mirror throwing a ball. One of the things that happens is you'll see as we get into it, these quadratic equations have a little bit of a curvature to them. So when we get into the graphs, but we won't get into the graph at this point, but we'll just kind of look at this problem just as it is right now. So after how many seconds does the ball hit the ground? So one of the things I can do is if I put this in the calculator where S is actually going to stand for Y in the calculator, and instead of using this T, I'm going to use X here. So 80 plus 64T, or 64X in my case, minus the 16X. Oops, that's not X. There we go. Keep hitting delete, and there. Don't have to start over. Now I need a square. 80 plus 64X minus 16X squared. So if I look at the table of this, the X stands for the T. The T was time in seconds. So it makes sense to start with 0. Notice that if time really can't be negative, so we have to really start with 0. Notice that when the time is 0, the ball is 80 feet off the ground, which makes sense because it's at the top of a building to begin with. So if I draw a building over here, this building, and here's the ground down here, this building is 80 feet tall. So it makes sense that at 0 seconds, if you will, the ball is here. It's 80 feet off the ground. So if 1 second goes off the clock, notice that it was thrown vertically. It was thrown with an initial. That's how it was thrown vertically, so it was thrown up. But remember, when you throw something up, gravity starts to grab hold of it, and it starts to bend it. So notice how it keeps going up for a while here. And then it looks like around 2 seconds, it kind of peaks out. So at 1 second, it's here at about 128 feet. And then in 2 seconds, it's peaked out around 144. This is just rough. So we said 128. And then in 3 seconds, it's back at 128. And then in 4 seconds, 4 seconds would be here. It's going to be 80 feet off the ground. And then in 5 seconds, it's going to be back on the ground. So just by tracking the table, how many seconds does it take to hit the ball hit the ground? We can see that, well, this has to be t equals 5. How many seconds will the ball pass the top of the building on its way down? Well, we kind of see it starts out at 80, and here at 4 seconds, it's back at 80. So it looks like t would equal 4 seconds if I look at this from a table perspective. That kind of solves the problem just by using the graphing calculator. Now, if I wanted to use algebra to solve this, one of the things I would do to start with is rewrite this as negative 16t squared plus 64t plus 80 is equal to s. I like to have my quadratic part on the left side. And notice how this term is negative, so I put a negative 16t squared. Now, the first question says, after how many seconds does the ball strike the ground? So when it strikes the ground, notice that the ground is actually at a height of 0. So remember, on the ground, it's 0 feet off the ground. So my first equation for part A is actually negative 16t squared plus 64t plus 80 is equal to 0. So I've got this quadratic equation. Now, on this quadratic equation, something else we can do with equations like this is, what I can do is, it looks like this 16 can go in each one of these terms. So if I quit this here, what's 64? And I'm gonna go ahead and just divide by negative 16. That's gonna give me a negative 4. And if I divide 80 by a negative 16, that's gonna give me a negative 5. So what I can do, since this is an equation, I can divide everything by, I can divide all this side by negative 16, and I can divide all this side by negative 16. So when I divide all this by negative 16, I have to divide each term by negative 16. So notice how the negative 16s will divide out and leave me this t squared. 64 divided by negative 16, we said is going to be a negative 4. That's going to be a negative 4t. And then 80 divided by negative 16 is going to be a minus 5. That's going to equal 0. So to solve this quadratic equation, notice how the quadratic term has a coefficient of 1 in it. So if that's a coefficient of 1, we can go ahead and set up our two sets of parentheses. The t has to go here and here, because that's the only way to get a t squared. But what are the factors of a negative 5 that give you a negative 4? So there's only one pair of factors for a negative 5, 1 and 5. To get a negative 5, one of them's got to be negative, but since this is a negative 4, that means the bigger number's got to be negative. So that means that the last two terms have to be a positive 1 and a negative 5, and that still has to equal 0. So we do have it now factored and set equal to 0. We now just set each factor equal to 0. So we have t plus 1 is equal to 0, and we have t minus 5 is equal to 0. So notice that here you'd have t would equal negative 1, and t would equal 5. But remember, t represents a time, and a time cannot be a negative value here in this application. So the only answer is going to be t is equal to 5, and that's what we came up with. Now, if I want to solve part B algebraically, how many seconds will the ball pass the top of the building on its way down? So remember, if it's on its way down, to be passing by the building, it's got to be at the same height as the building. So that means it's got to be 80 feet off the ground. So when I write my equation, this negative 16t squared plus the 64t plus this 80, it's got to equal, instead of 0 this time, this s has actually got to be 80 feet off the ground. Now, to solve this equation, notice how I have to, when I subtract an 80, I got to subtract it over here as well. So when I move it over there, there's an 80 already there. So what we're picking up on then is that you have this negative 16t squared plus the 64t. This is going to 0 out, and this is going to 0 out. Notice how, again, to make this problem a little bit easier, I can divide everything by a negative 16. So if I divide this by negative 16, I can divide this side by negative 16. So what we have then is t squared, and this, remember how we did 64 divided by negative 16, that's going to be a minus 4t is equal to 0. So if we look at this quadratic, notice how there's a GCF of t. So if I factor a t out, when I bring a t out of t squared, that's going to leave me a t. And when I bring a t out of this 4t, that's going to just leave me the minus 4. So if I double check, t times t does give me t squared. T times negative 4 is negative 4t. So since it's factored, we set each factor equal to 0. T is equal to 0, and then t minus 4 is equal to 0. Well, this one's already solved, and I still got to move the 4 over. So t would equal then 4. So notice how we have two answers, but notice the 0 is where I'm still on the building. But they're asking for how many seconds will the ball pass the top of the building on its way back down. So they're not interested in the 0. They're interested in the 4 seconds. So that's why we set up here the 4 seconds as well. So notice how we can actually do it using our graphing calculator and looking at the table. Or we can do it algebraically, depending on the problem. We just got lucky that it was all integer math, because a lot of times in algebra, it's going to be fractions and decimals, where the graphing calculator gets to be a little bit more challenging.